Hello everyone, my name is Nasr Azwan Alang. Welcome back to my video. Part 5, Torsion. In this video, I will talk about the difference between statically determinate and statically indeterminate structures. A simple example of statically indeterminate problem will be discussed in this video. Before end of the video, the concept of stress concentration in circular bar will be explained briefly. Statically determinate against statically indeterminate structures. Let's begin with the difference between statically determinate and indeterminate problem. In the previous video of part 3 and part 4, you have been introduced with some example involving torsion and have seen how this problem was solved using the static analysis. We have applied the equation of equilibrium in order to determine the reaction and internal torque at the support and in the shaft respectively. The example that previously discussed are categorized under statically determinate problem or structure. In this video, we will closely look at the structure that is under statically indeterminate problem. Now, let's see what is the difference between statically determinate and indeterminate structure. Statically determinate structure is defined as the structure for which internal torque and support reaction can be determined from static or using equation of equilibrium. Meanwhile, the structures for which internal and support reaction cannot be determined from static equilibrium equation alone are said to be statically indeterminate. For statically indeterminate structure, the compatibility condition or compatibility equation is required in order to solve for the unknown. Now the question, what is compatibility condition? I will explain and answer it in the next slide. Pictures 11 show the shaft or circular bar AB fits at both ends and is subjected to the torque of 120 Nm at the middle of the shaft. Now, what is the reaction torque at support A and B? Can you solve it using only the equation of equilibrium? We start analyzing the shaft using the equation of equilibrium of summation of force at x direction is equal to 0. Using the equation, we obtain TA plus TB is equal to 120 Nm. The use of other two equations of equilibrium of summation of force at y direction equal to 0 and summation of moment equal to 0 do not solve for the unknown or reaction at support. Therefore, using the equation of equilibrium alone without any extra equation is not sufficient to find the reaction torque. This type of structure is called statically indeterminate. Since the shaft is fixed at both ends, we know that the total deformation or total angle of twist along the shaft must be equal to 0. Therefore, we can write that phi AC plus phi CB is equal to 0. We can apply this compatibility condition or compatibility equation together with equation of equilibrium to solve for the reaction torque at support. Again, the phi AC plus phi CB is equal to 0 is called compatibility condition or compatibility equation for the case of shaft in picture 11. Solving the equation of equilibrium and total angle of twist, we can obtain the value for TA and TB, which are the reaction torque at point A and B respectively. The problem of statically indeterminate in torsion is usually involve mechanical gears as shown in picture 12. Some basic equation or concept for gear analysis that required to solve that kind of problem are explained in the next slide. Analysis of gear. Let's closely look at the two gears, gear A and gear 1 and gear 2 in the pictures 13, which is in contact and rotates at speed of n1 and n2. Note that the gear contact at one point during the operation. For equilibrium condition, the reaction force at the contact point of gear 1 and gear 2 must has the same magnitude but opposite in direction. If the reaction force at gear 2 is represented by F, therefore the reaction force at gear 1 must be also equal to F. Free body diagram in picture 14 shows the reaction force F and F prime at the contact point. Based on this picture, the equation for torque for gear 1 can be written as T1 is equal to F prime multiplied by R1. And similar to gear 2, the torque is T2 is equal to F multiplied by R2. Also shown in picture 14, the arc length of S1 is equal to the arc length of S2. Please note that the angle of twist of gear 1 and gear 2, however, is not the same. Since the gear has the same magnitude of reaction force at contact point, we can write that the T1R2 is equal to T2R1. Similarly, as S1 is equal to S2, therefore R1 phi 1 is equal to R2 phi 2. This compatibility condition can be applied together with equation of equilibrium in order to solve the problem in statically indeterminate structure involving mechanical gears. What we have discussed in this video and previous video is based on the assumption that the circular shaft is made with uniform cross-section. The use of flange couplings, gears and pulley attached to the shaft by key in keyways as shown in picture 15 and other cross-section discontinuity can cause stress concentration. Special treatment must be taken in order to avoid premature failure that may occur at stress concentration point. To account this situation, the torsion or shear stress formula tau equal to Tc over J should be replaced by tau is equal to Ktc over J, where the stress concentration factor K is added to the formula. The value of K can be estimated from the graph in picture 16. This graph also can be found in many other reference books and also in the literature. This is the end of video of part 5. Till we meet again in the next video of part 6. Thank you. Bye bye.